On page 8 of your packet, we are going to see what a graph of a log function looks like. And I think this might help you a little bit in how you put the exponential form and the logarithmic form together and think about both of them collectively. It says, what do the graphs look like? I'm going to start over here with this that's in exponential form. Because we started this unit, I asked you to graph a function like this. Okay, thanks. How do we graph something that has an exponent that's a variable? How did we do that at the very beginning of the unit? Is it going to be a parabola? Is it going to be a straight line? Is it going to be a curve? What's it going to look like?
A line. No.
Go back and look at the front of your packet.
Oh, a curve.
It is going to be a curve, right? It's actually, since this is a value greater than 1, it's going to go like this. It's going to have an exponential, what I would consider an exponential form to it. But we made a table of values, right? We said x, y. What kind of values did we plug in for x?
Negative 1.
-1.
0.
0. 1. And then maybe 2. Or we put in -2 if we needed more values. Okay, if I plug in a -1 and I say 2 to the negative first power, what does that equal?
Half.
A half, that's right. Okay, and if I put in 2 to the 0 power, what does that equal? 1. If I put in a 1, 2 to the first is 2, 2 to the second is 4. And so if I plot that, -1 is at a half. 0, 1, 1, 2. We had this. And we walked through, what is the domain of that graph? All real numbers. Okay, what is the range of that graph? Its whole graph is above 0, right? So its y's are greater than 0. Is y ever going to equal 0? No. And it's never going to be a negative. Okay, let's skip the x-intercept, but the asymptote. I don't think I asked you for the intercept on the quiz. Where would the asymptote be?
I thought you just asked for domain and range.
I did actually get to include the asymptote. So where would the asymptote for this graph be?
X equals 0.
At y equals 0. It's horizontal, right? It's going to go through right here. So y is equal to 0. Okay, now we got that down. We did that at the very beginning. Now, when I graph a log, okay, in order to graph a log function, I want to put it in exponential form. So how do I rewrite this log in exponential form? 2
X.
What's the exponent going to be?
Y.
The y. Okay, it says log base 2. That's why 2 is in the base position for the exponent form. The exponent's always over here on the other side of the equal sign, and then x. Okay, so I make a table of values. This time, I'm putting in values for y. So if I took the same values that I plugged in for x over there and put them in for y, I'd get the same values, right? 2 to the negative first would be 1/2. 2 to the 0 would be 1. 2 to the first, 2 to the second. What happened? Jacob, put your phone away. Now that's on the video. Okay. What happened to my x and y values from one to the other? They just flipped, right? These are inverses of each other. Remember when we did inverses earlier in the year? And we saw the x and the y values just flipped in the tables? That's what happened here. Okay, I'm going to graph this in black. If I graph a half unit to the right, I go down to -1. 1, 0, 2, 1, 4, 2. Now I want to put an extra value in here. What if I did a negative 2?
Wait, why?
Because you can't quite see what's happening over on this side of the graph.
Oh.
Okay, so I'm going to put in one more value here. If I said 2 to the negative second power, remember I'm putting values in for y, so 2 to the negative second power would be, that's 1 over 2 to the second power, so what would that be? 1 over 4.
Wait, so do you have to add it to the other side too then?
I'm not going to because I saw the whole graph. I knew what was happening over here. I'm just going to add an extra value here because I want to show you what's happening here. At 1/4, so if I go just a quarter of the way, I'm going down to negative 2. Now, is there any value that I could put in for y that's going to make this x value equal to 0?
No.
No. Just like over here, there was nothing I could put in for x that would give me a y value of 0. I'm not going to get an x value of 0. So it's going to come very, very close to this y-axis, but it's not going to cross it, okay, and it's not going to touch it. Okay, so now if I asked you these questions about this, and I said, what's the domain? What's the domain of the black graph? So you think about the x values. The x values go this way on the graph. With the black graph only, is there any negative x values that were graphed? Over here, anything graphed? No, there's nothing there, right? The graph is stopping and it's not crossing 0 here. Nothing on this side. So now my domain are x's are greater than 0. How about the range? That's this way. So do we have negative values included? Yep, these y values are going to keep getting more and more negative. These y values are going to keep going up as they go out.
Yeah.
So all real numbers.
So it's basically just the opposite.
It's going to switch. Everything's going to switch. And now the asymptote. Where is the asymptote now located?
X.
Yeah, it's now going this way, right? It's now a vertical line. This is going to get closer and closer to that blue line, but it's not going to touch it. So because it's vertical, I now have to say the asymptote is x equals, in this case, 0. So what you see, you're seeing inverses of each other. Something in exponential form, this is the log form of it, that are inverses. So your table of values have switched, your domain and range has switched, and now your asymptote is vertical with a log instead of horizontal as it is with exponential form. Make sense? Okay, and keep in mind that we call these inverses because if I were to draw a line, a diagonal line here, this is the line where y equals x. If I were to fold that graph on that broken line there, these points would match up with each other exactly. Okay? Those two graphs are inverses of each other. Everybody have everything written down they need?
Wait.
Okay? I'm going to do another one, so take the one on the bottom here. It's asking us to graph this. Now, they're not going to ask you to graph both the exponential and its inverse today. They're just going to ask you to graph the log today. So when you get a log to graph, what you want to do is write it in exponential form. So what's the base of this? And actually, this is hard to read. This is supposed to be a log base 1/2. It was hard to get the 1/2 below. but the base is 1/2 to the power of y equals x. So take it out of log form, write it in exponential form, and then make a table of values. This time it's the y that's in the exponent place. So I'm going to put the values -1, 0, and 1. And now I'm going to evaluate. So if I have 1/2 and I raise it to the negative first power, what does a negative exponent do to a fraction? It flips it over. So this is the same as 2/1 to the positive first power. 2 to the first is just 2. If I take 1/2 and I raise it to the 0 power, anything to the 0 power equals 1. And if I take 1/2 and I raise it to the first power, I get 1/2. If I plot these 3 points, +2 is at, when x is 2, y is at -1. When x is at 1, y is at 0. Here's at, if I go a 1/2 unit over, I go up 1. Now, if you're not sure about what it's going to do at either end, you could keep putting more values in. Okay, I know from what I've done, it's going to go like that. So when we ask you for the domain, we're asking about the x values that you put in, or the x values that you could get out of this graph. What would you say for a domain? X is greater than 0. Okay, for a range, you're asking about the y values. So are the y values positive? These are going to get higher and higher and higher. This is going to get, as it goes out, it's going to get lower and lower and lower. So the range is going to be all real numbers. And where is the asymptote? Okay, the asymptote is running right here. That's a vertical line, so you got to say x equals
0. Will you ask us for the end behavior, like on quizzes?
I'm not going to ask for that on the quiz. If I was talking about the end behavior, okay, this would be as x approaches 0, y approaches infinity. Okay, this would be as x approaches infinity, because x's are getting larger. Y is approaching negative infinity, because it's going down. If I asked you for an intercept, now we don't have a y-intercept anymore. We have an x-intercept. We would say the x-intercept is at 1, 0. Or if you just said x equals 1 for the x-intercept, that would be fine. Okay? I've got a textbook assignment for you today.